Okay, so we're going to take a look at what our prime numbers are. Going to determine whether something's prime or whether it's a composite number. And from there, we're going to go ahead and practice factoring these things apart to prime numbers. All right, so number 9. Well, obviously 1 and 9 are factors, but we also have 3 and 3, right? So this would be these are all of my factors. 3 squared would get me 9. 1 times 9 will also get me 9. So my potential factors here are 1, 3, and 9. So this is not prime. This is a composite. Right? It's not prime, so it's composite. All right, so let's take a look at 30. 30. Well, we know that we have 1 and 30. And then we know that we have 2 and 15. Right? This ends in a 0, so it must be divisible by 2. 3 and 10. And 4 does not work, but 5 does. So I've got 5 and 6. All right, now these are all out of order. I'm going to go ahead and put them in numerical order. But the idea behind this is that we're able to see that this is definitely not prime, right? There's more than just 1 and itself. All right, so let me go ahead and put these in numerical order, which is the way convention says that you would write them. 3, 5, 6, 10, 15, and 30. All right, so there they are written in numerical order. As I say, that's going to be a convention of how you would write something down. You normally write them either in alphabetical order if you're dealing with variables, or you're going to write them in numerical order if you're talking in terms of numbers. All right, now let's take a look at number 41, right? And kind of a shortcut when you're going ahead and you're trying to figure out if something's prime or not, you're going to want to just stop and think for a moment and take a look at your prime numbers. If it's a composite number, it must be made up, at least partially, of a prime number. So let's go ahead and see if we can find a number that will work for this other than 1 and 41. So 2 doesn't work because it doesn't end in a 2, 4, 6, 8, or 0. 3 doesn't work because if I add 4 and 1 together, it gets me 5. 5 is not divisible by 3, right? That's a trick that you can use. If the digits of a number add up to being a number that's divisible by 3, then that whole number is divisible by 3. 5 does not work because it doesn't end in a 0 or a 5. 7, well, let's see. 7, we would have 5 times 7 is 35, plus another 7 is going to get us a 42. So that doesn't work. 11, it would need to be a 44. 13, you would have to have something ending, again, you'd have to have something ending with, well, 21, but it doesn't work. If I had 3 times this, right, I would wind up with 39. And if I have 4 times that, it's definitely bigger than the 41. And at this point, we're just about to the point where we wouldn't have to keep going. 17 times 2 is not going to get us the 41. And 19 times 2 is not going to get us the 41. And as of from here to here, we've now jumped so that we would be kind of capturing anything else. So at 23, 2 times 23 is going to get us a 46. So again, that does not work, right? And now we've kind of walked our way all the way up through to getting to here. So 41 is actually prime. right? So using the numbers that we know are prime to kind of check to see if something else is prime, that's a short way to go about it. Okay, so then here, let's try 57. Of course, we know we have a 1 and a 57, so that's kind of a given, right? Now, let's take a look. This doesn't end in a 2, 4, 6, 8, or 0, so this is not divisible by 2. Let's check and see if it's divisible by 3. So if I have a 5 plus 7, that's going to get me a 12. 12 is divisible by 3, so I know 3 times 19 is going to give me a pair, or it's going to create this number. So I have more than just 1 and 57, so this is composite. All right? It's not prime. So hopefully this is helpful just in kind of determining how to find prime numbers. And we're going to go ahead and we're going to factor further on a number of different other numbers here. So hopefully we can get real comfortable with pulling things apart and being able to cancel and factor things out.